Is that 2 or 220? Identify, oh, it's 2 comma. Yeah. Here, let me write that in for you. Oh, well, sorry, I forgot. My pencil needs to be connected. My Apple Pencil. Sorry, let me give 30 seconds. I could do roll, but nah. Okay, so there's a polar graph. And so let's go back to the question. They're saying, oops, what did I do? Oh, there we go. They're saying 225 degrees. They want me to identify the point. So this is the new system, the polar coordinate system, which gives you an R and a theta. It's like rectangular. So this would be rectangular, which gives you X and Y. So now we have 2 coordinate systems. We have the rectangular coordinate system, which gives you an over and an up, right? X is over, as you know quite well, and Y is up. Well, R theta is another way to identify locations, points, on the axis system, but you do it differently. Instead of over and up like rectangle, you do R and theta. Now theta is the angle. So remember, it's like you turn the cannon to that angle, and then R is the distance you fire the cannonball out. So let's go. I like to use the polar graph. Let's go back over here. So 225. So here's the cannon. The cannon is sitting right at the origin, and then you turn the cannon to face 225 degrees. That's this direction, right? 225, right there. So you turn the cannon to face that direction, and then how far do you fire in that direction? 225, you fire 2 units. Well, notice each of these circles, the way a polar graph works, is each of these circles is one more. So in other words, as you go to the right, this is 1, 2, 3, 4, 5, 6, 7, 8. So these are 8 concentric circles, 8 circles that all have the same center. That get, in the small circle's radius 1, the next circle's radius 2, radius 3, etc. So then if you want to turn the cannon to face 225 degrees and fire 2 in that direction, it's going 1, 2. There we go. There's the point. 2, 225. Turn the cannon to 225 degrees and fire a distance of 2. That easy enough? Let's go back. Which one is it? Is it this one? Yep. There it is. Questions on that? That good? Shall we keep going? So you turn the cannon to that angle and fire. So this time they're saying 5, pi. All right, 5, pi. Do you want to try that one? So make an axis system and turn the cannon to face the direction pi. So going back to the polar, what's the direction pi? Right there, huh? So the cannon is facing that way. Is that good? And was it 5? Go 1, 2, 3, 4, 5. Yeah, right there. There it is. There's the point. 5, pi. It's this dot right there. Face the direction pi and go 5. We good? So, is it A? A it is. We good with that? Questions I can answer? Okay, so -1, -4 pi/3. Okay, so they want us to turn to an angle -4 pi/3. Yeah, that's a little tricky, huh? You know what you should do with negative angles, like -4 pi/3, is just subtract from 360, and then you can get the positive one that's the same. Do you know what I mean by that? Is that making any sense? Like, for example, if somebody tells me negative, and let's just think about degrees for a minute. I want to show you it's true. If somebody says, hey, find the location, excuse me, -90 degrees. This is -90, isn't it? Y'all would be able to find that one right away. -90. So in other words, 0 degrees is to the right. 0 degrees is where we start. And negative is down, so you go down 90 degrees. That's negative 90. Well, that's the same as what positive angle? What's that the same as? Yeah. In other words, it's 360 minus that, isn't it? Do you see what I mean? Whenever you take 360, minus the negative angle, then you get the same positive answer, huh? So we can do that here. We can say, okay, let's do that with the negative 4 pi over 3 thing. If you just say, look, 2 pi, 360, minus 4 pi over 3, we can get the same angle positive version. Find the same location. Is that making sense? Just subtract from 360. So how do we do that? How do I take 2 pi minus 4 pi over 3? Over 1, right? Top and bottom by 3. And we get 6 pi over 3 minus 4 pi over 3, which is 2 pi over 3. Get this stuff out of the way. Is that making sense what I did there? Just do the common denominator thing. Right? Make 2 pi into 6 pi over 3. Subtract, you get 2 pi over 3. So basically this is the same as saying negative 1 comma 2 pi over 3. Does that make sense how I've changed the question? It's another way to say the same location, isn't it? Because positive 2 pi over 3 is the same cannon-facing direction as negative 4 pi over 3, isn't it? Okay, so now we can go to our polar graph, turn the cannon to 2 pi over 3, and what's that negative 1 going to do?
It's going to reflect it.
Yeah, the cannon's going to backfire, basically, negative 1. So let's face 2 pi over 3, so we turn to face 2 pi over 3, and then we backfire 1. So let's do that. So where's 2 pi over 3?
It's 120.
Yeah. 2 pi over 3 is right there. Yeah, so there's 2 pi over 3. So we turn the cannon to face the 2 pi over 3 direction, and then when we fire, it actually backfires 1. So instead of firing in the direction we're aiming, it's a backfire. It fires backwards. So what is backwards? Well, you can tell it's this line, right? There's the backwards. So it backfires 1, so it's just going to go right to there. It backfires right to there. Does that make sense what happened on that? Yeah.
I know there's also another way, like if you remember, like changing the 4 pi third to a degree, like
Totally.
and then doing it from backwards since both are negative, and like of course be like 0 180, but then you flip flop the other way, push 90 would be on the bottom if it's going negative.
Yeah, you could do it. You could do it all backwards. Let me show. I could show you that if you think that might be easier. I don't think it would be easier, but it wouldn't be much different. So take negative 4 pi over 3, stick in 180, so you get negative 4 times 180 over 3. 3 goes into 180, 60, negative 4 times 60, negative 240. So negative 1, negative 240. Let me show you it's exactly the same. So what's negative 240? Well, again, you could convert it to positive by just taking 360 minus 240, which is 120. Same place. So it's 120, which is exactly where we're headed, 120. So it's the same facing in the end, negative 1. So you got to go back 1. Ends up right there. Either way. Is that good? Does that make sense on that? Questions I can answer? So direction the cannon's facing, back 1. All right, so I don't know which answer that is. I can't tell. You'll have to look close at those. Looks like C kind of to me too, yeah. Okay, so negative 1 pi over 2. So here, let me put a fresh polar graph here. Okay, so this is number 5, negative 1 pi over 2. Okay, so try that one, number 5 there. Negative 1 pi over 2. Try that one. second, see if you can find that location. All right, how we doing on that? Is that making sense? So pi over 2, that'd be straight up like that. So we face straight up pi over 2, and then -1, so we backfire 1, so that'd be, oops, right there. Oops. A little bit of trouble. That's weird, the whole thing disappeared. I don't know what I did, but it all vanished. All right, let's try again. So facing straight up, then backfire 1 right there. Is that good? Is it all making sense? Because on Wednesday, we're going to actually make like graphs of these things, and they'll do like roses. They make like with petals. They'll come out with branches, and they'll do weird, they'll do all kinds of weird things. So you want to get, like always in math, you really need to keep up, because whatever you do one day, then it builds the next day. So you want to make sure you get this down, because Wednesday will be really hard if you're not able to graph points, because then we're going to like make whole entire graphs out of equations involving r and theta. That'll be our last section. So is that good then? So it's pointing straight up. It backfires 1 like that. Okay, yeah, so they're saying here's the r, here's the theta. They're giving me 5, 11 pi over 6. We could do that one. Here, let me just put it on the polar graph here. Number 6, right? Yeah, 5, 11 pi over 6. So number 6. 5, 11 pi over 6. So that's pretty easy for y'all, I'm sure. Just point to 11 pi over 6. Where's that? Where is 11 pi over 6? Where is it? Oh, yeah, thank you. There it is. 11 pi over 6. 11 pi over 6. So then we face the cannon in that direction, and we shoot in that direction 5. So 1, 2, 3, 4, 5. There's the point we're talking about, huh? Is that good? There's the point, 11 pi over 6, 5. Now, what they're wanting us to do is say, hey, there's other ways. There's actually lots and lots of other ways to indicate that same point. Let me show you what they're saying. They're saying, hey, first off, part A, can you say that same point by, on part A, it's an r that's greater than 0, so positive, but we want an angle, a theta angle, between 0 and -2 pi. In other words, put in common English, they're saying, can you say the same point with a negative angle? That's what they're saying. Can you say that same location with a negative angle instead of a positive angle? That's what this is saying, right? Theta is somewhere between 0 and -1 rotation. So it's a negative angle. If it's between -2 pi and 0, it must be negative. So that's the first thing. Then in part B, they're going to say, now say it by making the same location again, by making your r negative, backfire, in other words. And then part C, they're going to say, now say it by making the angle between 2 pi and 4 pi. They're just going to have us just make sure that we understand there are several ways to say the same angle. So let's do part A first off. Can we say the same location with a negative angle? So how do you say this same spot, this same dot, the same location, with a negative angle instead of this positive 11 pi over 6 thing? So negative angle would mean, as you know, coming down from the 0, huh? Yeah, so what's that going to be? Yeah, 360 minus the angle, or I'll just do it in radians, totally. So it's 2 pi minus 11 pi over 6, like that. And so, which is 2 pi over 1, like that. And then multiply top and bottom by 3. So 6 pi over 3. Oh, wait, oh no, what am I doing 3? 6, huh? What do you get common denominator? 6 there. So 6, top and bottom by 6. So let's try that again. So then that'll be 12 pi over 6 minus 11 pi over 6, which is pi over 6, but that's negative pi over 6. Did I lose you by doing it that way? Is that confusing on that? Yeah.
I have a question. So, if my question is coming off of the pi, would I add pi or would I still be?
Yeah, you would still subtract from 2 pi because it's all like what are they giving you? What's your exact angle?
Because mine's in the third portion.
Yeah, what's the exact angle?
4 pi over 3.
Yeah, 4 pi. You just do the same thing. Just take so 4 pi over 3, which is here. Yeah, to get the negative angle, you subtract 360. Right? Am I thinking right? Yeah. Yeah. In fact, guys, you know what? I'm not saying it very well. I mean, this is true. What I'm saying is true. But let me try to be more clear, because your question's a good one, and let me answer it all up. Let me put it this way. Basically, if you're here or wherever you are, and you want to know what's that same location negative angle, really you're saying go backwards 360 degrees. Does that make sense? Subtract 360, because then you're at the same location, huh? So it doesn't matter. So that's how this is different than those other ones we did with reference angles and things in that last test. Because I hear your question. It's like, is that similar to this? No, this is different. This is wanting to stay at the very same location, just back one full circle. So just subtract 360, you're going to be at the very same location, aren't you? No matter where you started. So that's the deal. So I'm not saying it very clear. So 11 pi over 6, just subtract a full 360, which is what? 2 pi. So do exactly what I did. But I put the 2 pi in the front. I think this is a little easier. Either way is okay. Multiply top and bottom by 6 again. So 11 pi over 6. So let me get rid of it. It's not this location, is it? Let me get rid of that. Okay. Anyway, back over here. So we're going to get 11 pi over 6 minus 12 pi over 6. So minus pi over 6. So this positive 11 pi over 6 is the same as negative pi over 6, isn't it? Because basically if you start here at 11 pi over 6 and you back up one full circle, you subtract 360, you end up at negative pi over 6. So you're at the same location, aren't you? Because you just backed up one full circle. So there we go. So there's their first answer. So the first answer they want to part A is we would say, okay, part A, the original thing you gave me, which is whatever it was, oh here, 5, 11 pi over 6, that's the same location as 5 negative pi over 6. It's exactly the same location because that's the same angle. Then in part B, they want me to find the exact location by making the R less than 0. Notice. They want the R negative, huh? Yeah. Less than 0. So how do we say, let's go back, how do we say this same location right here with a negative angle? No, I'm sorry, not negative angle. Negative R, a backfire. How do we do that? We got to point the cannon the other way and backfire, huh?
Yeah.
Does that make sense? Instead of pointing here at 11 pi over 6, we're going to point, so take this line and go backwards. Where does it go? So, right, let me see if this is where we're at 2 from here, then it's right here. See how I'm doing the same reference angle? It's 2 lines down from here. It's 2 lines up from the x-axis. See how it's the same amount from the x-axis in those 2 quadrants? That'll be the same line up. See how those are on the same line? Same direction. Does that make sense how I found that? Those are on the exact same line, right? 2 down from the x-axis, 2 up from the x-axis. Same reference angle. So face the cannon this way, which is what? 5 pi over 6. Face the cannon at 5 pi over 6. Face the cannon this way, and then backfire 1, 2, 3, 4, 5. Negative 5 on the R. And you'll be at the same dot, won't you? Is that okay? Is that making sense on that? Backfire 5? So we would say backfire 5 while you're pointing at what angle? This one, 5 pi over 6, which is the opposite direction. So you point the cannon in the opposite direction, but backfire 5, end up at the same place. Finally, part C. Am I racing ahead of you? Is that okay? Feel free to slow me down. Finally, part C says, hey, okay, back to r being positive again. Now give us an angle between 2 pi and 4 pi. In other words, more than one full rotation. So you just add a 2 pi this time, don't you? So take the original, and just add 2 pi to the angle. Because they want some angle more than one full rotation to the right. They want it between 2 pi and 4 pi, between one rotation and two rotations. They want it more than one rotation. So just add a 2 pi. So we just take 11 pi over 6 and add 2 pi. Put that over 1, multiply top and bottom by 6 for common denominator. 11 pi over 6, 12 pi over 6. What's that? 23 pi over 6. So part C is 5, 23 pi over 6. Same location, said with more than one rotation, positively. And there we go. We said the same location 4 different ways, didn't we? Questions I can answer on any of those parts. Is that all good? All right. Okay, so try part A. Part A says r is greater than 0 between 2 pi and 4 pi. So here's the original. Here's the original r and theta. You don't even need to graph it. Well, I guess you do. They're asking you for the first graph. Whatever. You could find that easy enough. 3 pi over 2. I think isn't it C? Looks like C to me. Isn't that 3 pi over 2 straight down? We do a new polar here. So 3 pi over 2, yeah. 3 pi over 2 is right down there. So, and what was it, 5 or 4? 4. So you go 1, 2, 3, 4. So there's the location we're talking about, right? Facing 3 pi over 2, facing straight down. Facing straight down and shooting the cannon a distance of 4. So this is 4, 3 pi over 2. So there's the location. Now what they want you to do is say it in part A with an angle that's more than 2 pi. Can you do that? Give you a second to do that. So what do I do to say it more than 2 pi? Yeah, just take that angle. 3 pi over 2. And add 2 pi. Add 2 pi. So put that 2 pi over 1. Multiply top and bottom by 2. 3 pi over 2 plus 4 pi over 2. What's that? 7 pi over 2? So there's the angle. So the answer to part A would be same r, 4, but now the angle is 7 pi over 2. That's going to be the same location, isn't it? But the angle's more than 2 pi. That good so far? And now, in part B, B's going to be a little more tricky. They want r less than 0, which means negative, doesn't it? And they want the angle to be between pi and 3 pi. I think the angle will naturally come out between pi and 3 pi. Go ahead and give it a try. Here, I think it'd be better if I put it on the polar graph for you. So part B said the r is less than 0. The angle's between pi and 3 pi. See if you can get that. R is less than 0 between pi and 3 pi. So same location, said negatively. And then part C, yeah, let's leave it at that. Give you a second there, try that one. Okay, so if we want, so our less than 0 means a backfire. We want a backfire that's going to land at that spot. So where do we face the cannon if we want it to fire backwards and end up at that spot? Where am I going to aim the cannon? Yeah, straight up, huh? Starting from the origin, aim straight up, and then a backfire will actually head down this way, won't it? Does that make sense? So the answer to part B would be, okay, I want to go -4, backfire 4, aiming straight up at pi over 2. So aim straight up at pi over 2, but then backfire 1, 2, 3, 4. -4, backfire 4 on that. Luke?
You just need the pi over 2 in between pi and 3 pi.
Oh, you're right. I didn't think about that. Yeah, the angle's supposed to be between pi and 3 pi. How am I going to, so in other words, pi over 2, the angle I'm giving them is not the angle, they're being real picky on this one. They want the angle between pi and 3 pi. So how do I give them the angle? You know, pi over 2, that's half a pi, huh? That's not between 1 pi and 3 pi. Half is not between 1 and 3. So half a pi is not between 1 pi and 3 pi. So what am I going to do with that half a pi to make it bigger? How do you find the same location bigger? Add a full circle. Does that make sense? Whenever you want more, you add a full circle. When you want less, you subtract a full circle. It's always add or subtract a full 2 pi, a full circle, because you want to end up at the same location, don't you? Is this making sense to everybody? This good? So yeah, so this same location, just add 1 full rotation, add 2 pi, because they want it bigger. So take pi over 2, add 2 pi, so put that over 1, multiply top and bottom by 2 to get a common denominator, and we'll get pi over 2 plus 4 pi over 2, which is 1 pi and 4 pi, 5 pi over 2. Yeah, so good. So thank you, Luke. The answer they want is -4, 5 pi over 2, because is that between 1 pi and 3 pi? It is, because 3 pi would be 6 pi's over 2. So 5 pi's over 2 is within that. That's right. Good, I didn't even notice that. That was an extra tricky one. So there's the answer they want. -4, 5 pi over 2. On that. Questions on that? Is that good? Happy? And then part C. I think that's enough. Part C is part C is a negative angle. So we're just going to subtract 2 pi, right? I'm not going to bother. Let's move on. All right, so yeah, so looking at those answers, which of those are the same as the original? Oh, it's all about the polar graph thing. So yeah, so if we go to the polar graph thing, here we go. Yeah, find what's the original one? It is 6, 150. So find that one first off, 6, 150. So here's 150, go out 6, so 1, 2, 3, 4, 5, 6. Right there, right? So there is 6, 150. There's the location we're talking about on the polar. Now, which of these is A the same as that or not? Is B the same as that location, or is that a different location? Is C that same? So basically just graph A, B, C, and D also on the polar graph and find which of those land on the same dot. That's what they're asking. Do you guys want, how about a photocopy for you real quick? Do you want, so is that coming out okay? Which ones are right? I can't tell just by looking. Oh, I guess I'll go through them quick. -6, 330. So what would that be? 330. 330 is this, and then go -6. Yeah, same thing, huh? -6, 330 is going to be the same thing because 330 is that direction. If you backfire 6, yeah, same dot, huh? Does that make sense how I figured that out? I'm sure you figured it out as well. Right? Point at 330, backfire 6, same dot. Same location. So A is the same, so I'll check A. Yeah, A is the same. How about B? Aim at 210. I don't think 210 is going to work, is it? 210's right here. If you aim at 210 and you backfire 6, you're going to be going back this way. 1, 2, 3, 4, 5. You'll end up here. That's B. No, that's not the same location, huh? Everybody see how B is a different location? And that's so B is a no. This one's a yes. How about C? C says negative 6, negative 30. If you do negative 30, oh yeah, that is negative 30, isn't it? 330 is negative 30. It's 30 below 360, huh? And then backfire 6, yeah, that's the same thing. If you backfire 6 at negative 30, that is another way to say the same location, isn't it? Right? If you're aiming at negative 30, if you're facing negative 30, right? Because 330 is 30 below 360, so that is negative 30. And you backfire 6, yeah, that's going to end up at that same dot. So that one's a yes. We'll check C. How about D? Face negative 210? I don't think so. What's negative 210?
150.
Yeah, if you take 360 minus it, you get 150. So 150 is... Well, am I in the wrong picture? Yeah, 150 is... Oh, it's going to work. 150 is this direction, and then they said go 6. Yeah. So this is also right. 6, 1, or they called it negative 210. Negative 210 is the same as positive 150. When you take 360 minus 210, you get 150. So positive 150 is the same as negative 210, right? Because if you take negative 210 and you add a full rotation, you're at positive 150, same place. And they said positive 6, so that shoots forward 6, same dot. So that one is also a yes. So A, C, and D are all good. Did you all get that? The others are, B is not. Good? Could you handle that kind of question on test? So that'd be multiple choice. Give like A, B, and C, and then D would say A and B but not C, and E would say A and C but not B, or, you know, all that kind of stuff. All right. Okay, so they're giving me the polar to 180, and they want me to find the rectangular. So they want me to change now from polar, from r theta kind of thing, to x, y. Because that is some point on a graph, isn't it? And they want me to find that point in the other system, the xy system, the rectangular coordinate system. How do you do that? What do you think? Remember what we've learned. If you turn to some angle theta, let's say, and you shoot out a distance r, right? This is the point r, comma theta, right? You turn the cannon, just stick with me for a second. I don't care about the specifics, just in general. You turn the cannon to some angle theta, and you shoot out a distance r, and you land at a dot, right? That dot is over how far? We call that x. Up how far? We call that y. So that's what we're wanting to change to. From theta r to find a dot to x, y. Same dot. We just want to find that same dot in the xy system instead of the r theta system. So what's x going to be? It's a little right triangle there, huh? Because x is straight over, y is straight up, so it's a right triangle. The radius is r, because that's how far out you shoot the cannon. The angle's theta, that's what you turn the cannon to. What do you think x is there? You guys are trig professionals here, now that we're at the end of our trig semester. That's easy pickings for you, right? What could I do to, what trig relationship would involve x and r? Yeah, because for theta, this is the adjacent, this is the opposite, this is the hypotenuse, huh? Right, from theta's perspective, this side is right next to theta, so that's the adjacent. This side is across from, it's the opposite, and this is the hypotenuse. So what trig relationship involves x and r? Involves adjacent and hypotenuse. Remember the old SOHCAHTOA? I'm sure you do. Which one has adjacent and hypotenuse? Cosine. So the cosine of theta is adjacent x over hypotenuse r. Right? And what are we trying to solve for? X. We want to know what x is. So how do you solve that equation for x? Multiplied by r on both sides. X equals r cos theta. That's how you find x. It's r cos theta. How do you find y? What trig relationship involves y and theta. Opposite over hypotenuse, sine. So in other words, the sine of theta is opposite y over hypotenuse r. Solve for y, multiply both sides by r. R sine theta is y. So just like we've seen so many times, haven't we? X is always cosine, isn't it? Right? On the unit circle, the x values are cosine, the y values are sine. When we're doing vectors, the x values are cosine, the y values are sine. Remember, we're doing those work functions with the dot product, with the vectors. It was always that way. It always is that way. So you can just know it right away. Whenever you're doing something with x, it's always the cosine. Whenever you're doing something with y, y is always up, down. It's always the sine. Okay, so if you want to find x then, it's r cos theta. So the r is 2. Cosine 180. What's cosine of 180? 180 degrees is right here. Cosine is, this is back 1, isn't it? So 2 times -1, -2. What's the y value? R sine theta 2 sine 180. What's the sine of 180? What's the height at 180? 0. So we get 0. So the point, the xy point, is -2, 0. -2, 0. Like that. There it is. Is that good? Is that right, by the way? Like, in other words, let's actually do that. If you turn the cannon to 180 degrees, that's facing this direction, and you shoot out 2, where do you end up? Yeah, back 2, up 0, huh? That's correct. That is the xy, same point as 2, 180. They're the same location. Is that good? So that's how you convert. There's the formulas for converting between r theta and xy. Just like vectors, huh? Exactly like vectors. Okay. So -1 comma pi. That's our r and our theta. Can you find x? And find y? Try that one. X is r cos theta, so -1 cosine pi. And the cosine of pi is -1, huh? So this is positive 1? Is that good? I think that's right. Oop, r sine theta. So r sine theta is -1 sine pi. That'll be -1 times 0 be 0. So the answer is 1, 0. Positive 1, 0. Is that good? How many got that? Got 1, 0? We good? Well, not so many. Questions I can answer on that? Anything I can say to help? Is it all making sense now? If you have a little trouble with the cosine pi, just use the unit circle if you're having any trouble on that, right? Because pi's right here. So that's back 1 up 0. Cosine, sine. Cosine's -1, sine is 0. All right, I'll keep. Okay, so this is the xy. It's saying the rectangular are given. Change it to r theta. So how do you go backwards to r theta? Well, remember the relationship again. Let me derive it for you again real quick. Here's theta, here's r, here's x and y, like that. So what's the relationship then between x, y, and r? You know, x squared plus y squared is r squared, huh? Right? If you're at any dot, which you can call r theta or xy, same dot, set in two different systems, then x squared plus y squared must be r squared because x is straight over, y is straight up, r is the distance out at an angle theta. So that must be the case. So how do you solve for r? R must be the square root of x squared plus y squared, right? So let's go over here and find r. R is the square root of x squared plus y squared. So now we're converting the other way from xy back to r theta. So that's the square root of 4 plus 4, which is the square root of 8. How do you simplify the square root of 8? Break it down. 2 times 4, 2 times 2. 2 2's in, send 1 2 out, 2 root 2. Remember, square roots are always the 2 for 1 deal at Target. This Christmas, buy 2 for 1. Did you guys take advantage of Black Friday? Some did. Did you get something good, Jeffrey?
Yeah, I got a nice luggage set.
All right. You got there early and got a good deal?
No, there's always stuff.
Okay. All right. My son was one of the first 100 at some store. I don't remember. Tilly's, that's it. He got a free Adidas blanket. Anyway. It's not worth getting up that early to me. But anyway. 2 root 2. So we got r, 2 root 2. And now how do we get the angle theta?
Oh, I know.
What's that?
You make the y and the x positive, you understand?
Yeah, exactly. It's the vector thing. Yeah, this is just the same as the vector hum. The polar coordinate thing is almost exactly this. Right on, Rudy. It's exactly the same as the vector. Remember how we do that? Theta. And yeah, because you can tell right here, right? The tangent of theta is y over x, isn't it? See from the, the SOHCAHTOA. Tangent of theta, you can tell, is just y over x. There we go, y over x. So inverse tangent, that whole thing. So just like for vectors, inverse tangent of y over x. But yeah, it could be in any of the 4 quadrants. So you know how you got to make those both positive, get the answer, and then think about which quadrant for the reference angle thing. Exactly like vectors. So it's kind of nice, isn't it, for the final? We've done, it's just the same thing again and again. So yeah, you'll have a vector question, you'll have a polar coordinate question for angles. It's all the same thing, isn't it? So, all right, so theta will be tangent inverse of the y over x. What's the y? The negative 2. Oh, but you're supposed to make it positive, huh? Make them both positive. Everybody good with me on that? Remember how we do that for the vector? We make the y and the x positive. Why do we do that? Because that way we get just the first quadrant, then we shift it. Excuse me. Excuse me again. Then we shift it to the right quadrant. So hit the buttons on your calculator. That's inverse tangent of 1. And that is 45 degrees. But that's just the reference angle. It's 45 degrees reference, remember, because we make everything positive y, positive x. That'll be the reference. So at first you just get the reference angle, which means angle with reference to the x-axis, huh? Referring to the x-axis. Okay, so it's 45 degrees off the x-axis. But which quadrant is this thing really in? Over 2, down 2. Over 2, down 2. It's really right there in the 4th quadrant. Let me make that a little bigger. Right, let me just do it right here. So our angle's really in the 4th quadrant. So, all right. So our angle's really, over 2, down 2. So it's right there. Over 2, right 2, down 2. A little right angle. So our angle is 45 degrees down from down like that. So how do I find the actual, from here to there kind of angle theta? 360 minus, yeah, right? Because you go all the way to here, 360, and then you back up 45. So 360 minus 45, whatever that is, 315? 315 is the actual angle. Yes?
So if you have your calculator say it in radians, you get like 0.78 as the reference. So should we just solve it in degrees first and then convert it to radians?
Or you could just do 2 pi minus your answer. That would get in radians.
Yes. They want your answer in radians, but they want exact, so you're not going to be able to give them that decimal thing. Does that make sense? Yeah, so you can't actually, that would be the right decimal to go 2 pi minus that. They don't want a decimal. They want exact answer. Right, so guys, do you understand? And gals, whenever they say exact answer, they mean they don't want decimals rounded. So you have to give them pies and things like that. Yeah, so we can't just use our calculator and give them decimals rounded. So do what I did, get the 45. I would just work in degrees. get the 45, convert it to 3, because 45 is the reference, so 315 is the actual angle, and then just convert that back to radians, because they do want a radian answer. So how do we take 315 and convert it? Take 315 degrees times what? Pi radians over 180 degrees. Right? Because that, how do you know it goes that way? Well, because that way degrees cancel. Degrees are, you always put on, whenever you're converting anything, if you take chemistry, they do this a lot. Whenever you're converting anything, you put on the bottom what do you want to get rid of. So this, because this is degrees over 1. So put degrees in the bottom, degrees will go away. So, okay, so what do I got then? So then I have 315 pi over 180. Everybody see that?
You have to turn into radians?
Yeah, right here they're wanting radians.
Okay. And that's the final answer.
That's the final answer. They want radians. Well, I got to simplify that. That fraction is reducible. So now divide top and bottom. I'm going to get this out of the way here. Get this out of the way. Top and bottom by what, 5? I guess. I don't know. It's getting messy. What is that then? What's 315 divided by 5? My calculator's here. What is this? 63? 63 pi over, is that 36? Oh, and then it divides by 9. So then it's 7 pi over 4. Whew. Yeah, 7 pi over 4. That's a lot of work. Maybe I should have just done pi over 4 from the beginning.
Or you can refer to your
chart. Yeah, good point. Any of the charts. Yeah, exactly. That's way easier, Jeffrey. You're right. Yeah, if you just look at this thing, 45 degrees down is right here. Right? 45 down is right in the middle. That's 7 pi over 4. That saves a lot of work. Yeah, let's just do that. 7 pi over 4. Yeah, so just find it that way. 7 pi. So the final answer then, after all that work, is what was the 2 root 2? The r is 2 root 2, comma, 7 pi over. Yeah, so really we should have done like Jeffrey's saying. Once we knew it was 45 degrees reference angle in the fourth quadrant, because it was right 2, down 2, 45 degrees, we should have just gone right to our thing and went, okay, look, it's right in the middle of the fourth quadrant. What's right in the middle of the fourth quadrant? 7 pi over 4. That's the radian angle. Much easier. Good? Thank you for that tip. Questions on that one? Turned out a little more painful than I thought. Hopefully it won't be as bad as the last one. So -1, negative root 3. See if you can convert it to r theta. So the r part's easy, huh? R is the square root of x squared plus y squared. 1 plus 3. So r squared to 4. R is just 2? Did you get r okay? That's the easy part, huh? Now do the theta, which is the inverse tangent. Make both those positive and get a reference angle. So just like for vectors, theta is the inverse tangent of positive root 3 over positive 1. Is that 60 degrees? Comes out 60 degrees. Yeah, then just, oh, but that's reference. I'll be a little careful, huh? Yeah, that's 60 degree reference. Now you got to go find what actual quadrant that's in. Look at the original coordinates. Which actual quadrant is that in? Back 1, down root 3. Wouldn't it be in the third? I could back 1, down root 3. So that's a third quadrant angle. down root 3 right there. So it's in the third quadrant. So that means it's 60 degrees off the x-axis in that quadrant, isn't it? It's this way. That's what a reference angle means, huh? It's always with referring to the x-axis, with reference to the x-axis. So, okay, so it's 60 degrees off the x-axis, like that. So how do you find the actual angle?
180 plus.
Good. Everybody see that? Everybody good with that? I'm getting more and more comfortable for y'all. Some things on the final you're just going to fly through because we've built on higher things. You know, you'll see as you look back over the final, I think, the beginning stuff, you know, where we just found sines and cosines of angles. You'll just laugh at that stuff. We've done so much of it now, it'll be easy for you. And some of the stuff was a little different. You'll have to remind yourself on. So 180 and then plus 60, huh? Yeah, so 180 plus 60, what's that, 240? 240, yeah, 240. Okay, and then, yeah, let's just go to our chart. 240, so 240 is right here, 4 pi over 3. I like Jeffrey's method of converting. Just go to the chart. 4 pi over 3. Either chart, the unit circle one or this one. I grabbed you ones that have radians and degrees both on them. So 4 pi over 3. So there it is, 4 pi over 3. So our final answer then is r, which is 2, theta, which is 4 pi over 3. That's the same point as the original one given in rectangular coordinates, now given in r theta coordinates. Good there? Questions on that? Keep moving. Okay, so now they're going to give me an actual equation. Is that? All right, so here we are. We have 3x plus y is 7. They want me to take an actual entire equation and convert it from xy, it's like a rectangular equation, you know, and convert it to r theta. That's kind of weird, isn't it? How do you convert from like an equation? It's not just a point. What we just did was points. Let me make sure you're clear here. Like this was a one dot on a graph. This was one dot right here. Back 1, down root 3. And we converted it to r theta, right? That was one dot. We went from rectangular to polar, polar, back to rectangular for one dot. But now it's a whole equation. Like, you know, this is a graph, isn't it? You guys are good at graphing linear things. If I could graph this, you don't need to write this down, but you know, you can just move this. They're not asking me to do this, but if you move that over, it'd be that, which is a line, right? What is the 7? It's where it starts. Remember, that's the y-intercept. It starts at 7. Then this is the slope. It goes down 3 over 1. So anyway, my point is that's a bunch of points. That's a million points, all in a straight line. That's what that equation represents. It's an equation which represents millions of points all along that straight line. It's what we call a linear equation. When x and y are first power, they make a line, linear equation. Okay, having said that, they would now like me to come up with an r theta equation that produces the exact same picture. That is the exact same, well, it's equivalent equation. How do you do that? How do you convert a whole equation, not just a single dot? How do you convert a whole equation from xy to r theta? Well, same way, same formulas, which means what was x always equal to? R cos theta. And what is y? Well, not cos again, r sine theta. Yeah, you just do the same thing. So right here where x is, you go, okay, x, you're now r cos theta. So 3x is 3r cos theta. And y is r sine theta. We good to there so far? So just use these same relationships. We're going to have these on your 3x5 card for exam number 5. X is r cos theta, y is r sine theta. And now, see how they want me to solve for r? So can you solve that equation for r? what do we do there to solve that equation for r? Yeah, Rudy.
When is that? The r cosine theta plus r sine theta formula used? When exactly do you know when to use that?
Like yeah, what these two?
Yeah.
Yeah, basically when they want you to change from r theta to x or y. Yeah, from polar. Yeah, good question, Rudy. Let me write a note here. It's used when you want to go polar to rectangular. You want to go r theta to xy. Either a point or an equation, either one. Good question. That's the kind of stuff I should be saying. Good. Thanks for bringing that up. So whenever you want to go r theta to xy, you use those two equations. Okay, so now how do you solve for r? What do you do to how do you get r alone?
You can extract it.
Extract it, that's right. Factor it out, huh? Take out the r, is that what y'all did? Oops, I almost wrote the r again. Sine theta. Like that, you just factor out the r, right? Because that r could just redistribute, huh? And then you could divide by 3 cos theta plus sine theta, 3 cos theta plus sine theta. Boom. There it is. R's alone. It's 7 over, I don't know if you can read that. I got kind of scribbly down there. It's 7 over 3 cosine theta plus sine theta. And we did it. We changed that xy equation into an r theta equation. Wednesday we'll graph them. We'll take things like this and we'll plug in r theta points and we'll put the dots on our polar graph and we'll find out this one's actually a straight line because it's the same picture as the xy one was. It's just r theta.
That's the final answer.
Yeah, that's all they want for now, is they want r alone, so that is r alone. That is the final answer. Does that make sense how we did that? Want to try another one? Questions? Okay, so there we have x squared plus y squared is 25. Now, actually, let me jump in. You of course could go x equals r cos theta and y equals r sine theta. That would work, but there's an easier way. So remember, I've given you the x's are so you kind of so maybe I should say you really want to use all these. Whoops. Let me remind you what I'm talking about. X is r cos theta, y is r sine theta. Yes, that's true. You actually could plug those in, but you know what an easier way to go is going to be? What other relationships have we learned? What is r equal? Pythagorean theorem. Exactly. Yeah, let me just write it that way. Totally. X squared plus y squared is r squared. Remember that one? So this whole thing is just r squared. Right? X squared plus y squared is r squared. So r squared equals 25 is the same as x squared plus y squared is 25, huh? Because r squared is x squared plus y squared. Make sense on that?
And
Ben?
it's like that because that equation is a circular equation, right? It's equation for a circle, right? The x squared plus y squared equals 25.
Yes, it is the equation for a circle. Exactly right. Yeah, I don't know if you know that from algebra. That's the equation of a circle of radius 5, and that's exactly what this is. That's all the points whose radius squared is 25. That's all the points whose radius is 5. What are all the points whose radius is 5? A circle of radius 5. It's the same graph. It's the same set of points. It's the same relationship. Does that make sense on that? Let me double. So these get a little more tricky. Okay, x squared plus y plus 9 squared is the same thing you want to convert. You know what I would do? These just, they're all a little different every time, which is never nice. So it really just requires practice. Because there's all kinds of things that might work. I'm telling you, I've just done them recently and figured out what did where I reminded myself a week or so ago, 2 weeks ago maybe, and you want to FOIL that out. Wait, is that right? Maybe I'm wrong now.
I think there's a problem where you complete the square and stuff.
Yeah, well, we'll get to that one. Yeah, I think this is the best way. Let's FOIL this out. You can tell I'm not 100% sure. plus 9y plus 9y. Oh yeah, this looks looking good. So I just FOILed out that y plus 9. Why? Why am I thinking? Let me give you my thinking a little bit, because you'll need to be thinking this way to remember all this. Why am I thinking that way? Well, because I want to get this x squared and y squared out into the open. Because as soon as I do, I'm going to go, boom, you're r squared. Remember, my goal is to change all the xy stuff to r theta stuff. And so I know if I can get the x squared and the y squared out into the open, I can change them right away. So that's what leads me to this kind of plan, plus 18y. Now the 81s we just subtract from both sides and they're gone. Getting kind of scribbly there. Right. Good to there. We're almost done. We still have to get rid of that y. We good so far? Everybody good to there so far? Now, what am I going to do with that solo y? Well, we already know y is our, not cos, our sine theta, huh? Keep writing cosine all the time. Y is our sine theta, isn't it? So I'm going to replace that right here. 18y will become 18r sine theta. Let me slow down a minute there so everybody see what I've done so far. So I FOILed out the y plus 9, y plus 9. And then x squared plus y squared is r squared. And the 18y, y becomes r sine theta. So now I've got all r's and thetas, no x and y. I've replaced all the xy stuff by r theta stuff, haven't I? Okay, am I done? Well, almost. Last thing is they are asking me to get r alone this time. So how do I get r alone again? Factor, right? Factor out the r. It'll be r plus 18 sine theta equals 0. Because if that r went boom, it'd be r squared, and went boom, it'd be back there too. I just factored out the r. Good to that. Now, you caught up? You ready? Because we're going to take a jump here. Little jump, but still a jump. If two things are multiplied, if I say, hey guys, I'm thinking of two numbers and I'm timesing them and it's coming out 0. What does that mean about the two things I'm timesing if I'm timesing them and the answer is coming out 0? Yeah, either one could be 0. Huh? The first one could be 0. 0 times anything can be 0. Or the second one could be 0. Anything times 0 would be 0, right? Either one could be 0. And that would be the truth. So that's what it means here. One thing times another thing is equaling 0. Two things are timesing to equal 0. So that means the first one could be 0, because 0 times anything would be 0. Or the whole second one, the whole thing, the whole second one, could be 0, because anything times 0 would be 0, right? The whole first one, the whole second one, either one could be 0, couldn't they? That's what that means logically, right? Okay, so what? Well, let's finish getting r alone here. Let's jump this to the other side. So r will equal minus 18 sine theta. So we've got two answers for r alone. R is 0, and r is minus 18 sine theta. Good so far? Right? Because again, two things are timesing to be 0. If two things are timesing to be 0, the first one could be 0, and that would make this true. Or the second one could be 0, and anything times 0 would be 0, and it would be true. It means these two things, either one could be 0, which means r could be 0, or r could be negative 18 sine theta. Now, I'm going to throw this one away. And the answer is only the second one. Why? Because the second one includes the first one. When you have this one, you also have that one. Now we're edging into graphing a little bit, and that's Wednesday's lecture. But let me just help a little bit. What does this mean? Like if you were to do a graph, so I've got to talk about graphing a little bit, and say I want to show you that this is really included in this. That's why it's okay to ditch it, because I haven't really lost it. This includes it and more. What do I mean? What is this? Well, if I said, hey, show me all the r theta, that's what we'll do on Wednesday. We'll make graphs like you do for XY tables, but we'll make r theta tables. We'll graph in the polar system. That's why you want to finish this homework before Wednesday so you're comfortable with the polar system, because we're going to push it quite a bit harder. We're going to graph in the r theta system. So how would you graph, like tell me what r, what theta could you plug in to that little tiny bitty equation and make it true? That's what it means to be a graph, right? Any x, y, or in this case r theta, that make the original thing true, they're on the graph. You guys with me on that? You're good with that fundamental concept. When I say y equals 3x plus 7, like I did a minute ago, right? Then I said I think it was negative 3x. Starts at 7, right? Goes down 3 over 1. We said it's this, it's all these points. Those are all the points whose x, y values make the thing true. For example, this point right here, over 0 up 7. You put in 0 for x, is x and y, 7 for y. That's a true statement. 7 does equal 3 times 0 plus 7. That's why the point, 0, 7, is on the graph. Go down 3 over 1, so subtract 3, from the y, Subtract 3 from the y, add 1 to the x. You want right 1. What's that? 1, 4. 1, 4 must make this equation true. Does it? 1 here, 4 here. Negative 3 times 1 is negative 3 plus 7 is 4. Yeah. 1, 4 makes that equation true. Thus, 1, 4 is a dot on the picture. And that's what's true of all the dots, the millions and millions and millions of dots that make this picture. Every dot on a picture makes the equation, the original equation, true. That's the membership requirement. You're in the club if you make the thing true. This dot over here, let's say it's 10, 4. 10, 4. It's 10, 4. It does not make the equation true. That's why it's not in the club, right? There's no prejudice in this club. It's just a simple rule. Do you make the equation true or do you not? So if x is 10, y is 4, that's not true. 4 does not equal 30 plus 7. Right? So that's true of any graph at any time, wherever, however high you ever go in math. That's always the truth of a graph. All the dots on the picture is the picture of the truth. It's the picture of all the dots for an r theta equation. So when somebody gives me an r theta equation, all the dots that end up on the picture, which is what we're doing on Wednesday, are dots that make the r theta equation true. Picture of the truth. In any system, rectangular, polar, whatever. So what? Okay, let's go back to r equals 0 now. I'm doing all this to explain to you what r equals 0 really means. What are all the dots that make this equation true? It's kind of weird when you only have one letter. Let's think about rectangular for a minute. What if I only had x is 5 or whatever? What are all the points that make x equals 5? Well, it's all the points with an x coordinate of 5. Like him, but all these guys also. All the points there are over 5. We don't care what their y is. As long as they're over 5 up anything, you put in 5 for x, there's nowhere to plug in the y. So it's true. Any point with an x coordinate of 5 makes it true. That's why the graph is this straight line at over 5, What about x equals 0? Well, that'd be a line right in the middle. All the points that have an x coordinate is 0. Okay. Same thing over here. What are all the points that have an r? R is how far you shoot the cannonball. Of 0. There's nothing in here about what angle. Aim the cannon whatever angle you want. Just shoot a distance of 0. What are all the points that are a distance of 0 from the origin? There's 1. The origin itself. Do you realize the graph of that is the origin? That's the only point that has an r of 0. That's the only point where the cannonball's gone nowhere. Am I making sense? So my point is, it's just the origin. This equation right here is just saying the origin. And this already includes the origin. Now, if it didn't, we'd have to do something, but it always does. This already includes, how do I know? Well, if r is 0, what angle theta works with that? Several angles. One of them could be the angle 0. Sine of 0 degrees is 0. 0, 0 is a point on this graph. So the origin is already on this graph. So it doesn't add anything to this equation. Say, hey, also remember the origin. He's like, I already got it. I already got the origin and much more. So that's our. And so in the end, this is our equation. This covers the whole graph. We don't need the other one. That's a long explanation for that, about why you can throw that away. So there's our answer. Make sense? I did all that because it was confusing to me. When I was 2 weeks ago solving through your homework, I'm like, hey, where'd the r equals 0 go? How can they do that? So it took me a while to figure it all out. So I wanted to share it with you. There we go. Okay, so y squared is 4x. Can you convert that to r theta? So what does y equal?
4x.
No, I mean like for converting. Is that a trick question, Mr. Harry? Y is our, you see I wrote cosine again. It's our sine. I just always want to write cosine. Y is our sine theta. So I would just plug that in both. Oh, and x is our cos theta, isn't it? So just plug those in.
But do you do like r sine theta squared?
Yeah, exactly. Yeah, so it'll be r sine, so it'll be r squared, sine squared, and the other side will be r cosine. And then you got to, they want you to get r alone, so same kind of thing, right? You got to get them on the same side, factor out the r. Same kind of thing we did last time. So y squared is r squared sine squared, and x is r cosine. Good there. And then because, is that good so far? And then because they want r alone, jump this part over. So we'll get r squared sine squared minus 4r cosine is 0. And then what do we do from there? Factor out the r. And that'll be r sine squared minus 4 cosine. And then basically you set each one equal to 0 separately. Right, because two things are timesing to equal 0. So that means either one could be 0 to make that true. So that second one, r sine squared of theta minus 4 cos theta equals 0. Good to there. And this part we're going to throw away because that's just the origin, like it was a minute ago with my long explanation. Bring this part up then. So we have r sine squared theta minus 4 cos theta equals 0. Solve for r. Right, because they want r alone. So now jump this back over. We're doing a lot of jumping back and forth, aren't we? Jump this back over, and we get r sine squared is positive for cosine. Divide by sine squared. And you get that. Now, you can leave it that way. Yeah, that's fine. Yeah, that's fine. Just leave it that way. You can make that, one of the cosines over sines can be made into a cotangent. But why bother? We don't need to do that fancy stuff. It's fine as it is. There we go. Well, yeah, maybe I should show that. I'll say or, because on the multiple choice thing, maybe they'll have it that way. Right, you can make that 4 cosine over sine times 1 over sine, right? For the sine squared in the bottom, you could break that. Am I confusing you? Yeah, I'm running out of room too. So this is a fine answer we have right here. Let me put it up here. I'll say or. Or you could say, look, that's 4 cosine over sine times 1 over sine. Right, if you wanted to separate them. And then that's 4 cotangent theta times what? What's 1 over sine? Cosecant theta. That's the same answer. So you could leave it this way, 4 cosine over sine squared. Or if you broke that up into, broke the sine squared in the bottom into 2 separate, and then cosine over sine is cotan, 1 over sine is cosecant. You might see it this way in a multiple choice answer. I think you will, in fact, now that I remember making that test up. They might have it like this. I think Math Excel will take it either way. Yeah, I'm sure they will. Let's go try it. Yeah, so I think on the test it usually looks this way. But my Math Excel will take it either way. Is that good? All good? All right. Couple more. Now we're going to start going the other way. Now, this is the last thing. Good, we have about 15 minutes. Last thing in the section, they're going to start with the r, or maybe r theta, in this case just r, and they want you to go back to xy. So now we're converting. So this section is all about getting more comfortable with converting between rectangular and polar. Now they want me to convert the whole equation backwards from polar. They're starting with polar, go back to rectangular. Well, you know, again, the main things r squared. Oops. You see the answer right there. You can see what I did, huh? R squared is x squared plus y squared. So what does r equal? Square root of x squared plus y squared. So this r right here is square root of x squared plus y squared. And so last thing is just go ahead and square both sides. And you get x squared. Right, the squaring cancels the rooting. 13 squared is 169. There it is. That's a circle of radius 13, if you know how algebra equates 13 squared, which is what this is. This is all the points whose radius is 13. That's a circle of radius 13. Is that okay? So it's mainly really just these equations, and the x is r cos theta and y is r sine theta. Just keep converting. Just keep going. Theta is 7 pi over 4. That's weird. Theta is 7 pi over 4. All they're giving me is an angle. How do I convert that to like an XY kind of thing? Yeah, theta is tangent inverse. Remember what we've learned about theta? It's tangent inverse of y over x, but then we got all the, yeah, that's a little, could do that. Right. Yeah, I guess so, yeah. So theta is tangent inverse of y over x, right? We've been using that conversion a lot. Vectors, polar, same thing. So therefore this theta is tangent inverse y over x is 7 pi over 4. Makes sense so far? I just replaced the theta on the left with tangent inverse of y over x. So, now what? Now, if the tangent inverse of y over x equals 7 pi over 4, then that means y over x is the tangent, the regular tangent of 7 pi over 4. Did I lose you there? Does that make sense? How about this? You could just take tangent on both sides. Would that be easier? Take tangent on both sides. These cancel because they're tangent and tangent inverse. And the other side, so this is just y over x. This side is tangent of 7 pi over 4. How about that? Is that easier? Way to see that? So when you have tangent inverse on one side, you could just take tangent of both sides. It cancels out the tangent inverse. They're opposites, right? Tangent and tangent inverse. They cancel each other out. And so we get y over x equals tangent of 7 pi over 4. So what is tangent of 7 pi over 4? Got your unit circle?
Oh, 315.
And so the tangent so 7 pi over 4. It's right here. Now remember, this is cosine and sine. Tangent is sine over cosine. Tangent is negative root 2 over 2 over root 2 over 2, right? Sine over cosine. So tangent is negative 1 for 7 pi over 4. Everybody with me on that? That good? Tangent sine over cosine. Sine over cosine. Negative root 2 over 2 over root 2 over 2. So going back, tangent 7 pi over 4, negative 1. They want me to get, scribbled it here, they want me to get y alone, notice. So then just multiply both sides by x. Cancels out, y is negative x. I converted from theta to yx. Y equals negative x in particular. Is that okay? Did I lose you in that process? A little tricky. These take some practice. Put some of these on your 3x5 card. These are a little tricky. They took me a little practice. I had to circle them in the book and try a couple different things so I got it to work. So these are harder. You might see what I did? I just said, look, theta's tangent inverse, and then I took tan of both sides, canceled out the tangent inverse, and then tangent 7 pi over 4 in the unit circle, negative 1. Solve for y. All right. Okay, now they're giving me r cos theta is 8. They want me to go back to xy. They want the rectangular. I'm going to do this one quick. What is r cos theta? That's x. All that's just x. So x is 8 done. That one's a snap. Good? So r is 8 secant theta. Now what is what's secant? Good, good, very good. So this is 8 over cosine, really, isn't it? Cosine at the bottom. Okay, so what? Totally. Put that cosine on the other side, because then I'll get r cosine, and that's just x. Yep, you guys see it coming. Exactly. Just multiply cos theta to both sides, and we get r cos theta is 8. And what is r cos theta? X. Is that the same answer we got last time? Yeah. Good on that? Same thing? Let's keep. Hope I don't stumble around too bad and waste all of our time. What are we going to do with that one? Oh, yeah, I remember now. Okay. Okay, r equals 12 cos theta. That looks weird at first. It does to me, too, because I'm looking at the cosine thing, and I'm thinking I need an r here. You know, if that was just r cos theta, then I would know just to replace it with x. So I'm trying to replace, with x and y, right? And I'm remembering, well, x is r cos theta, and y is r sine theta. So I need the r in there, and I just have a 12. I don't have an r. So multiply both sides by r. That's the trick on this one. So multiply both sides by r. So this is r squared, and this is 12r cos theta. You can put that r anywhere. I'll just stick it in the middle there. And now I've got my r cos theta, which I can replace with x. See the trick? So that r cos theta is just x. And what is r squared? Remember what r squared is? X squared plus y squared, huh? So this is x squared plus y squared is 12x. That's the trick, how to change it all into xy. Now, they've done some fancy footwork with completing the square, like Wendy was mentioning. One of these is the same as what we have here. Which one is it? Yeah, you know how you can tell? If I was to bring this 12x over, it'd be x squared minus 12x plus y squared is 0. Do you see that?
Yeah.
Do you remember completing the square? They've completed the square is what they've done. Let me bring this up here. So x squared minus 12x. I'll leave a little room. Plus, remember completing the square? Did we do it in here? I can't remember. Did we do it in here?
I don't think so.
Okay, anyways, the thing from algebra. You grab the one in the middle. Basically, you want to put in a third thing here to make this factorable. So what it is you take the middle one over 2, square it. Negative 6 squared, 36. That tells you to add 36. But if you add 36 to one side, you've got to add 36 to the other to keep the balance. Does this seem kind of wild and crazy all of a sudden these last 2 minutes? So I'm figuring out now. See, now this will factor. Minus 6, minus 6. See that? And this side's 36. See how that made it factor nicely? Did you all see that? If I was to FOIL this out, it would be x squared minus 12x plus 36, wouldn't it? See how that 36 was just what it needed to make it factor as the same thing twice, in other words, squared. And so there it is. Answer C. Oh, no, not C. Which one is A? A, yeah. A. Everybody see that? Oh, yeah.
Where do you get the negative 12 over 2 from?
12 over 2. Yeah, it's the formula for completing the square from algebra. Yeah, you always take, whenever you want to complete the square, and complete the square, I wish I had more time. I'm glad to help you upstairs more. But basically, whenever you have something and you want to make it factor as the same thing twice, make it squared. That's what we call it, complete the square. Give it what it needs to complete it. It's always the middle number. It's middle number over 2 squared. So I just took the middle, I put it over 2, and squared. That's the formula for how you find the completing number. Middle over 2 squared. Yeah. Well, these took a long time here at the end. So 26, let me show you the trick. R squared sine 2 theta is 4. There's a formula which is hard to remember. Sine 2 theta is 2 sine theta cos theta. Right? Not true? Sine, sine, cosine, cosine.
Is that from the identities?
Yeah, it's one of the identities, double angle formula. Right. Yep. So anyway, you replace this with 2 sine theta, because we can't have double angle like that. So then you get that. Everybody good so far? I'm just running out of time, so I'm going to whip it. Divide by 2 on both sides. Separate these r's. So it's a little bit of trickery here. See how I separated the r squared into 2 separate r's? Why? Because then r sine is y, r cosine is x, x times y is 2. Solve for y. Divide by x. Y is 2 over x.